All right, well, good morning, good afternoon, good evening. Again, whenever you listen to the videos, watching the videos, here we are. We're talking about polynomials. We're dividing in section 5.7. We've done multiplication in section 5.6. In section 5.5, we did addition and subtraction. So we're pretty much going to be done with polynomials, at least working with them. Later on, we'll work probably a little more extensively with them. But this is kind of the basics of how to work with them. So we're going to do division here with polynomials. So here's what we're going to talk about: division of polynomials. We're going to talk about well, the book actually talks about division by a monomial and division by a polynomial. This section is going to talk about division by a monomial. So let's take a look at a monomial. What's a monomial? A monomial is a polynomial with just one term. A polynomial in this instance would be a polynomial with more than one term. So today's section we're going to talk about division of a polynomial divided by a monomial, but divided by just one term, or a polynomial with just one term. So dividing a polynomial by a monomial can be summed up right down here. In order to divide a polynomial by a monomial, divide each term in the polynomial by the monomial, and then simplify. I call this separate and conquer. I can't call it divide and conquer because well, that would be too applicable. So we call it separate and conquer. Separate and conquer. So let's take a look at what we've got here specifically. If we've got a, b, and c are polynomials, a and b and c, or a plus b is a polynomial as well, c is not equal to 0. That's important because we can't have division by 0. That's the only reason that c can't be equal to 0. Then what this statement up here says, which says, remember, in order to divide that polynomial by a monomial, divide each term in the polynomial by the monomial, separate and conquer. What I mean by that is, by the separate and conquer means that you take each of the terms that are in, or each of the polynomials, I guess, the monomial here, that's part of this big polynomial, divided by c. And then take the second one, let's change this into green, take that second monomial or term in the polynomial, divide it by what's that monomial that's in the denominator, and you've got two different divisions. You've separated, and now we can conquer them. So here's our a over c, here's our b over c, and then, oh, by the way, we need to really pay attention to, hang on a second, make this red. We need to pay attention to the sign that's here. If this is a plus sign here, we need to put a plus sign here. And oh, by the way, if there's a minus sign, the minus sign would go between these two divisions here. So that's what I mean by separate and conquer. Separate is a divided by c turns into a divided by c. B over c turns into b over c. The plus sign stays here, or if it's a minus sign between them, the minus sign goes between them. And then conquer. The last thing we have to do is simplify. So we'd have to simplify a over c and b over c if we can. And let's do some examples. All right. So remember, how to divide a polynomial by a monomial. Here's a polynomial here in the numerator. Here's a monomial here in the denominator. We're dividing a polynomial by a monomial. What do? We separate and conquer. So let's take a look at our first separation. We take a look at that division. Here's our first monomial divided by a monomial. That's our blue one. Here's a green one. Here is then the red one. And we're kind of separating and conquering. So we would write, and then when we write these down, we again have to pay attention to the sign that's between them. But for all intents and purposes right now, I'm taking a look at just the monomial divided by the monomial. So let's take a look at what we've got here. I've got 5a cubed divided by 5a. So my first separate and conquer is here. I'm separating 5a cubed divided by 5a. And then we put the sign. I'm going to make sure we put the sign. Let's put this in green here. There's green minus 10a squared over 5a. And then we put the sign plus 20a over 5a. And now we've separated. There's our separation. And now we've got to conquer. By conquering, I mean just by simplifying each of the blue and the green and the red. So 5 divided by 5 is 1, so we've got to make a kind of a place marker there. So there's a 1 there instead of the 5 and the 5. a cubed divided by a to the first power is a to the third minus 1 is a squared. And we can put the 1 here for the coefficient or the numbers. The coefficient would be 1, but we don't really have to put it there because we kind of understand there's a 1 there if we don't put it there. All right, so there's our first separate and conquer. For our second separate and conquer, we put the minus sign there, and then we start simplifying. How many 5's going to 5? 1. How many 5's going to 10? 2. And now we've got a squared over a. We could put this a long way as a times a, and then one of the a's would cancel out, and we'd have just a left. But we can also use our rules for exponents and say a squared, or a to the second power, divided by a to the first power. Again, there's an unwritten 1 there. 2 minus 1 gives us a to the first power, or just a. We don't have to write the first power if we don't want to, if it's just an a. And then the exponent, or sorry, the coefficient, the number that's in front, is 2. And sorry, that should be in green. Sorry, I'm canceling stuff out and writing it the same ink. It should be in green. There's our green term right there. 2a to the first power, because it's a to the second power, divided by a to the first is a to the 2 minus 1 is a to the first. All right, now let's cancel out over here. How many 5's going to 5? 1. How many 5's going to 20? 4. And I've got a divided by a. As long as a is not equal to 0, we're okay, because a divided by a would give us 1. And what do we have left? Just 4. I'll see if I can remember to put it in red here. Plus 4. There we go. And there's our answer. All right, so those are the steps. Separate and conquer. If you've got a polynomial divided by a monomial, separate and conquer. Here's the blue, here's the green, here's the red. Pay attention to the signs when you rewrite the separations, and then start canceling out, and that's the conquering part. So there's our answer. Now, your turn here is over here, but before we do that, let's just take a look at what this looks like. This looks just looks a little bit different from this one over here. This one has a divided by sign like there, that big divided by bar, divided by the 5a, and the numerator is down here. Sorry, the numerator is up here, the denominator is down here. Over here it just looks a little bit different, so let's just make things just the same. And we'll say this is divided by negative 6y squared z. All right, so there's our question. I've just rewritten essentially this right down here. There's the question. You guys work on this, and I'm going to ask you to pause the video and add to your notes all these questions. Remember, you're taking notes as we do this. To add to your notes, so I can take pictures and add it to your Dropbox. So pause the video here, work on this one, and we'll come back, and hopefully you've got the same answer that I get in the video. All right. So we have, again, a polynomial divided by a monomial. How do we do that? We separate and conquer. We take a look at that one. And then we take a look at that one. And I'm going to leave the signs alone. And we take a look at this one. It's important to remember that we're dividing by this negative 6y squared z. So the negative is part of the denominator. That's part of what we're dividing by. So let's take a look at what we've got for our separation here. 12, this becomes 12y squared z cubed over negative 6y squared z minus 15y z squared over negative 6y squared z. And you could have taken a shortcut and said, well, you know what? If we're subtracting a negative, because this expression here, this divided by here, 15 divided by negative 6 will become negative. If we're subtracting a negative, it becomes a positive, and you could have put a positive and a positive down here. But as long as we're following our rules here, I'm going to say this is 15y z squared here, and this is negative 6y squared z right down here. And then just pay attention to the signs later on. All right, in red, it's going to be plus, our plus sign, 6y squared z over negative 6y squared z. And now we've separated, and all we have to do is conquer. Let's see if I can use my black ink here. All right, how many 6's going to 6? 1. How many 6's going to 12? 2. Keep the negative sign here. We'll pay attention to that later on. Y squared divided by y squared is 1, as long as y squared is not equal to 0. Z cubed divided by z is z cubed divided by z to the first is z squared. So right down here is z squared. 3 minus 1 is 2. 2 divided by 1 is 2. for our number or our coefficient, and the negative sign has to come out in front because a positive divided by negative makes the whole thing negative. Go to the next one. Still, oh, sorry, and that should be blue. I apologize. Let's see, 15 divided by 6, we're going to cancel these out. How many 3's going to 6? 2. How many 3's going to 15? 5. Y divided by y squared gives me a, well, now let's go here and give me a y down here in the denominator. This could also be looked at as y to the first divided by y squared is y to the 1 minus 2 is y to the negative first power. But y to the negative first power becomes y to the first power in the denominator as well. So that's another way to look at it. Z squared divided by z gives me just a z on the top. Or if you want to follow the rules, z squared divided by z to the first is z to the first power. 2 minus 1 gives me first. So now let's write this down as, in green, let's take a look at what we've got here. 5 divided by 2, just in terms of numbers, and we'll take a look at the signs later on. 5, I've got, in the numerator, I've got 5z over denominator 2y. And now we're subtracting a negative, because this division here is a positive divided by negative is a negative division here, or a negative term here. So that would be negative, but we're subtracting the negative, so that means we're really adding a positive. We could put subtracting a negative here. We wouldn't be wrong, but it's prettier, mathematically prettier, to put that plus sign there. All right, in the red, what do we have? I've got, let's again take a look at the signs later on and just take a look at what we've got here. In general, we've got 6y squared z over 6y squared z, and everything can cancel out. You can go through and do each one individually. 6 divided by 6 is 1, y squared divided by y squared is 1, as long as y squared is not 1. Z divided by z is 1, as long as z is not equal to 0. And I think I said y squared is not equal to 1, as long as y squared is not equal to 0, as long as z is not equal to 0. We're okay by canceling that stuff out. But we do have to put a 1 here as kind of a placeholder, because 6 divided by 6 is 1. So there'd be a 1 here and a 1 here. Y squared divided by y squared is 1 and 1. Z squared divided by z squared would be 1 and 1. And then essentially all we have is 1 up here in the numerator, 1 in the denominator. 1 divided by 1 is 1. And so that's our number. There has to be a placeholder there for that. 1 in red. And we're adding a negative, because it's positive divided by negative. This divided by here, this division here, is going to be a negative, but we're adding a negative, so we're really just subtracting. All right, so that should be our answer. There is our answer. And so if you didn't get it, you can always rewind, go back and take a look at where you took a wrong turn, maybe zigged instead of zagged. All right, so that's the answer. Here's your homework now. Your homework to kind of get into class. Do this, put it into your notes, take a picture of it, add it to the Dropbox so you can get into class. Here's your question. 36 a to the 4th minus 48 a cubed plus 12a squared, all divided by a monomial of negative 6a cubed. All right, so that's your homework to get into class. Make sure you do it, add it to your notes, bring it to class, and we'll just go from there. Bring your questions to class, and we'll go through division.